recall when we're solving systems of equations, we can have one solution, we can have no solution, and we can have infinitely many solutions. And so we're going to take a look at a couple of these, and I have screenshotted some things from my calculator so that we can identify when we've got either infinitely many solutions or no solution. So here's my system of equations. 3x minus y minus 5z equals 9. 4x plus 2y minus 3z equals 6. And negative 7x minus 11y minus 3z equals 3. And you can see here that I had input all those coefficients and the constants in a 3x4 matrix. Now, and then I went ahead and ran the reduced row echelon form feature of that matrix A, and I come up with something like that. Put that in a different color. Something like that. And I'm thinking, what in the world? Now, this row of zeros right here, think about that. If column 1 represents the x, and column 2 represents the y, and column 3 represents the z, and 0 is the constant for each row, what that last row is saying is that 0x plus 0y plus 0z equals 0. Well, of course, that would be true. And when we see our reduced row echelon form come back like this with all zeros in the bottom row, then we have infinitely many solutions. Now, when I look at these other rows, other than infinitely many solutions, what else do I have? Well, let's look at row 1. So that 1 in column 1, row 1, column 1 is 1x, and there's 0y, and then there is minus 1.3z equals 2.4. And if I solve that for x, then I'm going to have that x is equal to 2.4 plus 1.3z. All right, well, what about row 2? Well, there's no x, 0x, but I got 1y equals 1.1z equals minus 1.8. And again, if I solve for y, then I'm going to have 1.8 minus 1.1z. So how do I express my answer in this case? Well, like this. So x is going to take on what we found right there, 2.4 plus 1.3z, comma, and y is going to be that, negative 1.8 minus 1.1z, and then finally, comma, z. So we would have infinitely many solutions, and we would write our solution, that unique system, in this form right here. Let's move to the next slide and look at another system. All right, so here we got a system of x plus 3y plus 4z equals 8, 4x minus 2y minus z equals 6, and 8x minus 18y minus 19z equals negative 2. And you can see again, I have entered that into my matrix A, which is a 3x4 matrix, 3 equations, 3 variables, 1 row, 1 column for the constants. And then I end up here with a row that says 0, 0, 0, 1. Now, let's think about that. If x is 0 and y is 0 and z is 0, just like in the first one it said equals 0, well, that would be true. But 0x plus 0y plus 0z cannot equal 1. And so therefore, this is just simply a no solution. So when you see all zeros in your bottom row, doing your reduced row echelon form, you've got infinitely many solutions, and then you solve for the specific variable, in this case x and y. But when you see a 0, 0, 0, 1 in the bottom row, it's just simply no solution.